what is UART? So UART is a universal asynchronous receiver and transmitter protocol. In which how many pins do we use?
2.
Which can you please name them?
Transmit and receive.
Correct. So in UART communication, we use 2 pins, that is TX pin and RX pin. TX pin that will transmit the data, and RX pin will receive the data. Then UART and USART, there is a little bit difference between them. If we use universal asynchronous receiver transmission, it is UART. But if we synchronize UART using baud rate and other things, then this will be known as USART. Correct? Guys, reply.
Yes, sir.
So, tell me what is baud rate? Anyone from you?
Number of bits per second.
Okay. So, bits per second that will be transmitted or received is known as its baud rate. So, if I have to communicate between 2 UART or 2 controllers using UART peripheral, what we have to do? We have to configure their baud rate similar, equal. So, if baud rate of device 1 is 9600, then baud rate of device 2 should be 9600, and if baud rate of first device is 115200, then the other device would also have same baud rate. Because if the rate of data transmission is not correct or not equal in both devices, UART communication will not work and data will not get transmitted. After that, we learned about modes of UART. So how many modes are there in UART?
3 modes.
3 modes. Can you name them?
Polling,
Polling, interrupt, and DMA.
DMA modes.
Polling, interrupt, and DMA mode. What is DMA mode?
It's like a direct memory access mode, like
yeah. In DMA mode, we directly access. Yeah. And in interrupt mode,
until the information gets
start and stop.
Okay.
Yeah, Chandan, sorry for the interrupt. Like
Yes.
One I got, like bitrate, baud rate, both are same or different?
Bits that is transmitted per second, it is only known as baud rate.
Okay, means both are same? Like
Yes,
if someone
yes,
asks what is the bitrate and baud rate?
Yes.
Okay.
When we are
Somewhere I read like signals per second, like number of signal, like
no, bits per second.
Okay, Sanjan, okay, thank you. Yeah.
Okay. In data transfer, we transfer bits and data in form of bits and bytes. So
Yes,
in
yes.
1 second, if we are able to send 10 bits, then its baud rate is 10. If we are able to send 9600 bits, its baud rate is 9600. So
Okay.
it's bits per second.
Okay. 9600 means in 1 second we are sending 9600 bits. Hello.
I think Chandan, facing network issue, I guess.
Okay.
Chandan, are you there? Hello. Hello. Chandan, your voice is not coming actually.
No, Chandan just now texted me in our group like power, no power.
Okay.
Okay.
There is no power. That's why I got disconnected. Please wait 2 and 3 minutes.
Okay.
Okay. We'll wait 2 and 3 minutes. If power can, then it's fine. Then if not, then we can think about what we can do. Okay.
Yeah, guys. Why I'm asking that question? Like somehow I also read there. Like, have you ever got this type of question? What is the baud rate and bit rate? Madhav or Hatim or Anil? Hatim, are you there? Hello.
Sir, basically, I'm driving. We'll reach at
Okay.
5 minutes. So that's why I'm not speaking.
Okay.
Okay, fine.
Yeah, Madhu, have you ever heard that type of question like bit rate and baud rate?
Yes, sir. That is quite a frequency like that, sir.
Frequency only, like.
Like transmission time it takes like that. It is like 9,600 like that is there, sir.
Bit rate means like, yeah, as per Chandan said, no? 9,600 bits per second means per second we are sending 9,600.
Nice, yes, sir. That is a common, sir.
Bit rate.
Constant,
Yes.
9,600.
For whom it is constant?
For all, for that, the baud rate is all constant, that like only some 9,600.
No. Not like that. 115200 also there, na? Yesterday Chandan told.
For the using, which is using for transmission, we can use that two options is there.
Different baud rate.
Yes,
But
yes.
whatever the bit rate we settled, entire communication that is fixed one.
Yes, sir.
Yeah, okay. Any other question related to this one? Okay, general question. Now one question came in my mind. Like, which is best one? Like with clock or with baud rate? Which is better one? Anyone? Madhu?
Clock only, sir.
Clock only. Why not a baud rate?
Because clock means it can be used for long distance also you can use, sir. This you can get on transmitting.
Okay,
Because
long distance means how long?
like you can use like one protocol is the SPI.
Okay. But suppose, okay, I got the point. Like as you mentioned, like if for the longer distance we can use clock.
Yes, sir. Because SPI is a synchronous.
Okay. Is the CAN is synchronous or asynchronous?
CAN is synchronous
CAN
and synchronous.
Synchronous? In CAN, have you ever seen clock? Madhav, have you ever used the CAN?
No.
Okay. Yeah, Anil, like in CAN, like how we communicate by using like clock or baud rate?
Actually, I have no idea regarding the CAM particularly.
Okay.
This is the first time I'm learning about embedded mostly.
Okay. Sudhir, in the CAN, have you ever seen the clock?
Yes, sir. It is used for synchronous and asynchronous, sir. It can be used for long distance because based on my knowledge.
Yes. It's a long distance, 40 meters long distance, like up to 40 meters. You can use that one.
You can use.
Okay,
both
like
you can use, sir.
In CAN, both can use.
Both can use. Based on my knowledge.
Okay. Then, as you mentioned, based on knowledge, like how the clock is there, like in our terminal also, CAN high, CAN low, only with two terminals only have. But where you have the clock related terminal, for suppose if you take high to C and SPI, there is a clock terminal is there.
Yes, sir. I2C is short distance. I can use for the sensors like that.
As per my knowledge, like CAN is baud rate only I can use.
Yeah, correct.
Yeah,
CAN is
no
baud rate
clock.
only.
Yes. And one more thing. Okay, as you mentioned, like clock means longer distance, and that is different then, because clock, there is no clock in the CAN, but we are transmitting up to 40 meters. Even though we have the clock in 81 SPI, but we are sending more than that. Okay. Anyone want to discuss on that? Like, which is better one, clock or baud rate? Anyone have any other point? Or anything, any topic I can discuss? Meanwhile, Chandan will join.
Explain this board rate and clock concept, the difference between board rate and clock.
Come again, Hatim. Like baud rate and okay, Sandeep told baud rate and clock. Na Hatim, you're asking about.
Yes.
Okay, clock and baud rate. Okay, baud rate means like how many bits you're sending per second. Okay, but as per my knowledge, I'm thinking like baud rate means how many signals we are sending per second. Like
Okay.
we are the pulse now. How many pulse we are sending? That is, I think, baud rate. Sorry.
Okay.
Bit rate. How many bits per second is bit rate?
Okay.
Okay.
And
I am also still getting confused now. Like, but as per Chandan told, na, like
No,
how many bits?
but the
yeah.
base question is baud rate and clock is a two different concept, or baud rate is a part of clock?
Baud rate and clock. Both are different, I think so. Baud rate and
different, correct.
clock. Okay, Chandan came. Better.
Chandan,
Yeah.
join, na?
Yes, आगे.
Chandan will explain. Yeah. Hello, Chandan, are you there?
Yes, maybe connected with mobile data.
Hello?
Yeah, Chandan, you are audible.
Yeah, sorry, there was power cut.
Yeah, Chandan, is it
that,
fine?
my
Like,
Wi-Fi
I
got-
think you connect with mobile data. Is it fine?
Yes.
Okay, Chandan. Okay, carry on.
I have just connected with mobile data only.
Okay.
My Wi-Fi got disconnected.
Okay.
That sorry for that. Yeah. Okay. What were we discussing about? I think it was about baud rate, correct?
Yes.
Okay. So baud rate is nothing. Number of bits that will be transmitted in second. That's called baud rate.
Okay.
Generally, when we use UART communication, then normally average controllers of STM32, they transmit around 9600 bits per second to 1152 triple zero bits per second. So you can see in general, if you select any microcontroller at default baud rate, it will show you either 9600 or 1152 triple zero.
Yes.
That means that controller can send that much number of bits in 1 second.
Okay.
From one board to another board.
Okay, Chandan.
Okay.
Okay.
So I think Hatim was having some discussion with you regarding baud rate.
Yes, he asking about like is that clock is part of baud rate or
No.
yeah.
Actually, we don't use clock in asynchronous communication. If we use clock, then it will become synchronous communication, and clock is train of pulses. If if you will send data according to the pulses, like high pulse, low pulse, then it will all. If we connect around 100 200 clock pulses, then it will make one clock.
Okay.
So clock is different, but we need we need something using which our data can be transmitted from one board to another board in UART
Okay.
communication. For that purpose, we cannot use clock here. So for that purpose, baud rate was initiated there.
Okay.
So that will determine that board A will send data at this rate. So board B will receive data at this rate. So baud rate is nothing, just it's a command that will tell at what speed the data should be communicated.
Okay. Yeah, Hatim, you can raise your hand.
Yes, Hatim.
No, sorry, by mistake.
Okay.
Yeah.
Okay, then thank you. Yeah, thank you for the clarity.
Okay. Then we understood about UART communication in three modes. First is polling mode, then interrupt mode, and then in DMA mode. Okay. So in polling mode, the CPU will continuously transmit data from one TX pin to another RX pin. Okay.
Yeah, sir.
In interrupt mode,
Sir, office is in Kodmangla, sir.
sorry. Did anyone ask any question right now?
Continue, sir.
No, Chindan, no.
Okay. So in polling mode, CPU will check all the communication and it will monitor the TX and RX status flag. In interrupt mode, CPU is free until interrupt is triggered or data arrives. When the data will arrive, that means if transmitters have already transmitted the data and that data arrives at RX pin, at that point CPU will get back to the work and it will generate an interrupt and it will tell RX pin that you have some data at your gate, kindly respond to my interrupt and receive that data. Okay, so in interrupt mode, CPU is free. It will only get activated or it will only work when the data will receive at the RX pin or the transmission is already completed. Okay. And the third one, DMA mode, in this data will be directly, DMA means direct memory access. So in this, data transfer will take directly from memory and it will be used for transmitting large amount of data in chunks. So the speed of DMA transmission is very high. Interrupt is medium because it will wait for some microseconds to generate interrupt. Okay. We have already discussed all these things in previous classes. It was just a recap. Then we tried some hands-on workshop in which we saw how we can transmit data using UART to serial terminal like Docklight and also receive data. Fine. So I'll show you once again. Just let me know when my screen is visible. Is it visible?
Yes.
Okay. So this is our STM32 cube ID. Here first I have all. You all guys knows how to generate project, right?
Yes.
Okay. So I'll show you the IOC file. In IOC file, we will go to this section, connectivity. In connectivity, you can see I2C, LP UART, QSPI, SPI, UART. So we selected UART. Okay. In mode, select asynchronous. Then in NVIC setting, select UART1 global interrupt because we will be using UART in interrupt mode. Fine. Then we will go to parameter setting. Here you can see baud rate. So its default baud rate is 115200. If you want, you can just right click here and change it to 9600 or anything. But we will keep it as default one. Then here in this IOC file, you can see these two pins, PB6 and PB7 are configured as.
Sir, voice is not visible, sir.
Sorry. What? Please speak again.
Maybe while you are speaking something, right? You can just speak, right?
Okay. So here you can see in this pinout view, PV6 and PV7 are selected as UART, RX and TX pin. Fine. Then just go there and generate your project device configuration tool code generation. That will take you to this page, main.c page. Here we saw if we want to transmit some data, then we need to store it in some buffer. So for that purpose, we made a buffer uint80tx buffer. Here we gave ASCII values of A, B, C, D, E, F, all things. So ASCII value of A is 65. So we started from 65 to 74. Then we are also, okay, first I'll just comment it. First we will only see about transmitting data. Then in while one, because we want to transmit data regularly, so in while one we write this code HAL UART transmit, and we are using UART in interrupt mode. So we used HAL UART transmit interrupt. I will show you once again how to write this. Just write HAL HAL UART. We want to transmit, so transmit, and then press Control and space. Press Control and space. You can see there are three options. First is HAL UART transmit. It will be in polling mode. HAL UART transmit DMA. This will be in DMA mode. HAL UART transmit interrupt. This will be in interrupt mode. So we have configured our IOC file in interrupt mode. So we select this. Now in place of UART, you need to select which UART you are using. So we are using HUART1. Then data. So we have already stored our data to be transmitted in TX buffer. So we will give TX buffer. Here you can give size of data, that is 10, or also you can use size of operator, size of TX buffer. Both are fine. If you have any problem, then please speak up. After that, we give some delay of around 1 second so that our data will be transmitted continuously with delay of 1 second. That means every 1 second our data will be transmitted. This is receiving code, so I will comment it. Now our code is ready for transmission. So we will build it. Then run it or debug it. It shows no ST-Link detected because my board is not connected to the laptop. Now I will connect it. You can see this node WB55RGI. This GUI displays that my board is connected. So now I will once again debug my code. Okay, we are ready to go. Just click on resume icon. Our code is started. Now we will open some serial terminal like Docklight. Here it's already connected, but I will disconnect it and show you once again. Okay, now it's disconnected. I cut this. So you need to install serial terminal like Docklight, TerraTerm, anything. So I have installed this Docklight. This one. Just click it. It will get open. Cut all these things. On the top right corner, you will see COM port. Right click it. Then in this drop down, select the one COM port which have virtual ST-Link. So you can see I have just connected one port and it's showing ST-Link virtual COM port. If you guys have 4-5 USB connections or other connection, then there will be 4-5 ports showing there. So you need to select the one that have written ST-Link virtual COM port. I have selected it. Here you can configure the baud rate. So baud rate of our board is 115200. So we'll keep it as it is. Okay. Fine.
Yes.
Okay. Then on the left top corner, you can see a start communication. Just click it and you can see I have transmitted A to J data. So A to J data is continuously printed here with 1 second delay. Any issue till now?
No.
Okay. So we are good to go. Now I will disconnect this connection and we'll move once again to the coding part. Now we will see receiving part. So I have already transmitted data from my controller to serial terminal. Now I will receive the same data. For that purpose, what we need to do, we will sort our two pins. I have one controller and on that controller I have UART 1. So pins of UART 1s are PB6 and PB7, correct? So first I'll write the code, then I'll show you the hardware connection. So just go there and like we made one buffer for TX, similarly we will make one buffer for RX. RX buffer will have nothing here because it will receive whatever the transmitter would have sent. Fine. Now here on line number 100, we all need to write this code. HAL UART, similarly to transmit, here you have to write HAL UART receive and then press Control and space. Again you can see UART in polling mode, UART in DMA mode and UART in interrupt mode. So select interrupt one. Now which UART we are using? We are using UART 1. In this receive we will use RX buffer because we are receiving the data here, and size will be size of RX buffer or 10. Fine. Any issue till now? I think no issue, so I'll continue. Then we have this code to transmit. Now in the receiving function, we need to make one callback function. So from where we will get this callback function? In STM32 QID, press Ctrl and H. Then right here UART callback and search. You can see here many options have come. So we will select first option, whatever it will. And in this file we will search once again Ctrl F, UART callback or RX complete callback. So here you can see this function is defined here, HAL UART RX complete callback. Just open this function. You can see this is a weak function. Copy this function. Control C. Now we will cut all these things. And in our main code, we will go to user code part 4. That will be below here. So just paste this function which we copied. Okay. Now here we have to make a callback function. So write HAL UART receive and control space. Select interrupt 1, UART 1, RX buffer and its size. Now this callback function have many functionalities. This will be used for transmission of data also, receiving data also, interrupt generation also, and many more applications that we will learn after some classes. Right now we have simple task, that is to receive the data. So we will just use receive function here in this callback. Now we will, if you will double tap on this line number 262 or whatever line, then a breakpoint will get generated here. So a breakpoint is already generated here. Now we will cut this and check our code by debugging it, building it. You can see 0 errors and 0 warning here. Now we will build it, but before building it, I will show you guys how to make the connection. So this is my controller, this is ST-Link and it is connected to the laptop. Now we have two pins, RX and TX. This is jumper wire. We will just connect this RX terminal with TX terminal. Fine. Now there will be some questions how to know on which pin we have to connect for RX and TX, correct? For that we will move on to the schematic. STM32 schematic. Open it. Can anyone tell me on which pin we have selected UART RX?
PB6.
So just search here PB6. So here you can see on connector CN10 we have PB6 here. Everyone can see it?
Yes.
And PB6 is here on pin number 34. It is connected to pin number 34 of connector CN10. Okay. So on your board you can search on the actual hardware. You will see remarks written like A1, A2, A3, CN1, CN2, CN3, CN4. So we will have to find CN10, that will be on rightmost corner. And on CN10, we have to select pin number 34 for PV6. Similarly, PV7 is there. Same connector, pin number 6. So what we will do, we will connect this pin number 6 with pin number 34. Okay. Any issue? Any doubt?
No.
Okay. So now we have connected our RX pin with TX pin. So what will happen? This will work as a loop. In loop, what will happen? TX will send the data, and that data will be transmitted to RX pin. But now both pins are connected with each other, so this will work in loop, and the data that will be transmitted from TX of same board will be received on RX of same board. If we would have two boards, then we will connect RX of board 1 with TX of board 2 and TX of board 1 with RX of board 2. So any doubt regarding the connection? I'll just paste it in the chat box. If you have any doubt regarding this connection, please speak.
Can I say one, sir?
So I'll write here board 1. So its RX pin will be connected to TX pin of board 2. Here I'll take board 2. So RX pin of board 1 will be connected to TX pin of board 2, and TX pin of board 1 will be connected to RX pin of board 2. Can you see this in the chat box?
Yes.
Okay, so we are good to go with our connection. Now we will check our code. So we will place this breakpoint in callback function. Already it's placed here. Now we will debug our code. Resume it. You can see this callback function have taken this breakpoint. On this breakpoint, where we are receiving this data that is transmitted from transmitter. Here we have made two buffers, right? One is to transmit and one is to receive. So which buffer is used here to transmit?
TX buffer.
And which buffer is TX buffer is used to transmit, and for receiving?
RX buffer.
RX buffer. So we will check here RX buffer. Just place your cursor here. You can see name RX buffer and details ABCD to J. So what does this mean? Our RX buffer have received some data that are A to J. Correct? And we have transmitted in TX buffer same data, SKY values of A to J. So we have received it here. One more thing you can do here on the right side, just go in the expression and enter RX buffer. When you will open it, you can see A, B, C, D, E, F, G, H, I, J. and their sky values are there 65, 66, 67, 68. That means these data are received in this RX buffer, which means we have successfully transmitted data using UART and we have successfully received data using UART in interrupt mode. Any doubt or any issue till now? Please speak.
Chandan, can we pass like object type data in this UART?
You can pass any data in this UART, but I wanted to keep things simple. So just pass these things like ABC.
No, because my question is the way you have explained. So here,
Yes.
if you want to pass A, B, C, D, E, F, G, H, I, J,
Yes.
we are passing A, B, C one by one.
Yes.
Okay. But A, B, C, D, E, F, G, H, I it's a one word, like
Okay,
one
so
word.
you want to pass a string here, correct?
Yes.
We can also pass it. Let me show you. Here, I'll change it. What's your name?
Hatim. Okay.
3, 4, 5. So it's 5.
Hmm.
Make it 5. Again here, make it 5. Here also 5. And in callback also we will make it 5. Fine.
Yes.
Now we will build our code to check if there is any error. No error. We are good to go. See, string Hatim is received here.
So H, A, T, I, M will come one by one. Is this the case?
It depends on you. If you use interrupt mode and you want to receive one byte at a time, then it will get received like HATIM.
Okay.
But in this, we have passed all these things as a single string. So here you can see all these things have been received as single string here. This thing which you are talking about.
Yes.
So, okay. So in buffer, we make. Do you know about array in C programming?
Yes. Yes.
Okay. So what does this mean?
Array start from 0 index.
Okay. So there is something called indexing.
Yes.
Okay. So the string Hatim is passed here and it is received as a string here. But we have made a buffer and it takes some register or address to be stored.
Okay.
So indexing is displayed here. Out at index 0, H is stored. Index 1, A is stored. 2,
Okay.
T is stored. But if you want to see what we have overall received, just in the detail section you can see it.
Okay.
It's a single string. Previously, when we were sending 1 byte at a time, then it was one string A, then comma, second string B, then comma, third one C, then comma D, E, F. It was like that, correct?
Okay. So Chandan, can you please add one more string like Tekri, Hatim, comma Tekri? So 2 different string in the buffer.
In
So how
same
it
line.
how it behave?
In this only,
Yes, comma
comma.
outside. No, not inside the string. It is yes, comma.
Okay, then you want to make 2 strings and then transmit and receive it. Then we will need to make some changes in this callback.
No, so when we are passing 72, 73, So
Yes.
it is not same like Hatim comma Tekri.
Okay. I'll show it.
Hmm.
TEKRI.
Yes.
Okay. Correct. You want to pass this?
Yes.
Okay. And its size will be
10.
5, 6, 7, 8, 9, 10.
Hmm.
Right?
Hmm.
Let's pass it and see what it will give. Okay, fine. Once again, we will build our code.
Hmm.
There is error.
Yeah, I will tell Chinnan, sorry for the interrupt.
Yes, yes.
Yeah, Hatim, like whatever the protocol we are using, UART. UART is character-based protocol, okay? Like if you see the frame format of UART, first start bit, then after data bits, then after
End
parity bit, then stop bit, sorry.
Okay.
Okay,
Stop
means it can send byte by byte. Means once it can send 1 byte, then after 1 byte. Like HATIM. Like that you can send. But suppose if you want pass like these two messages like Hatim and Tekri, we have to take here like array of pointers we have to take.
Oh,
But
okay.
as of now we are taking here array only, character array.
We
That's why same
left
like yeah, same character array and array. String means character array only, as and can then taken like their ASCII value taken like 65 and all.
So Hatim itself become an
Array
array.
only. Yes, character array only,
Yes.
Okay.
Okay, but if you want to send two messages, then it can pass. Like if you take character array, like array of pointers.
Okay.
You got the point. Like UART means it can send character by character, it can transmit.
Okay. Similarly here, if you want that Hatim and Tekri both will be transmitted, so either we can use it in the same buffer, like that.
So how to
just
manage?
Yes,
Okay,
just,
in the same string. Okay.
yes, just add some comma or any special character you want.
Okay.
So this is the first method. Now it will get transmitted. Just calculate its size 1, 2, 3, 4,
10.
5, 6, 7, 8, 9, 10. Fine. We will run it. You can see Hatim Tekri is received here.
Okay.
That thing that I wanted to, the error that we received, so I wanted to explain something to you. That's why I showed the error. Now, what you wanted is like you want to pass two string or two array.
Yes.
But in other, like in buffer 1 and buffer 2, correct?
But like Avinash,
Yeah, one second. Just type in the chat box what you want to transmit. I'll explain here.
Okay. Where is chat? Okay. I want to pass this. Like first it come Hatim and then take like it come A, B, C, D, E, F, G. We have passed 72, 73, 74 like that.
You want Hatim? Then we have to take two different array. Or you can use array pointer to pass this.
Array pointer. So can you please explain that method, array pointer?
Have 10 minutes. Okay. So, do you know about pointer and array?
Yes.
So explain it.
So pointer is basically to use where we want to link the address of that variable.
Okay.
And array is like multiple values
Multiple
with their index.
indexing, right?
Hmm.
So if we are using array 1 and array 2, then we will use a pointer that will point to the address of array 1 and array 2.
Okay, two different array.
Yes, because we are using two different arrays, so the pointer will be used to point out to their base address.
Okay.
Okay, so in that code, you will need to modify this, then pass two arrays, use a pointer that we will use in, I think, when we will use some external sensors.
Okay, fine, no issue. Okay, please
At that
continue.
time, pointer will be used.
Okay, no issue. Please continue.
Okay, so I hope this will be clear for you.
Yes. Clear. Please continue.
Oh. So now we have successfully transmitted and received our data using UART peripheral. If anyone have any doubt, please speak. Actually, I planned today to complete LED using switches, but due to some circumstances, our yesterday lecture was not recorded, so I was just giving a recap. So now, if you guys have no doubt regarding this,
yesterday we are facing one issue related to the debugging part, right?
yes. We were facing issue like we were not able to receive what we were transmitting.
Right.
Yeah, so for that purpose, I have sorted two pins, RX and TX pin. I have explained this 10-20 minutes earlier. You can see in the chat box what we have done. We have connected RX pin with TX pin and TX pin with RX pin. And using this, we are able to receive our data.
Yes. But without SWOT, you said yesterday.
Yes, using serial terminal, yesterday we were not able to receive it because terminal pin of my controller board was damaged. So I will repair it in this week and will show you once again.
Yes, sure. I am asking that one only because.
Okay. So now, can we shift to another project?
Yes.
Actually, I want to complete the third project today. For that, I'll close this. I'll give one task to all of you. I have shown all of you guys how to transmit and receive data in interrupt mode of UART, correct?
Yes.
So the task is, this will be till Saturday because our next class will be on Saturday. So the task is, now you guys will have to receive and transmit data using UART in polling method. Okay. So for polling, you need to do what I'll tell you. Just select the IOC file, select all the pins that I have shown in interrupt. In NVIC, we selected interrupt, correct? Because we are using UART in interrupt mode. In polling mode, you don't need to select this. Just keep it as it is. Then your UART will be in polling mode. Similarly, in the code here, so in the code, similarly, when you will write HAL UART transmit control space, oh sorry, I am writing this in code, user code 4. While one, I can write here. So when you will write your code HAL UART receive or transmit. Then here we were using this function, interrupt function. For calling you will use first function. Okay.
Okay.
So this is a small task. I hope you all guys can do this. If you face any issue, you can connect with me. I'll tell you how to resolve. Now we will move to the switch part. So we will close this project. I'll open this, but I'll show you how to. We will make one project. All till now, you all guys must have understood how to create project in STM32. So I will not show you every time how to create it. Is it fine with all of you?
Yes.
Yes. Okay. So just create a project and give it name blinking switch. Then go to the schematic part. And here just search LED. LED toggling I have already taught in first class. You
Yes.
guys were present?
Yes, yes.
Okay. So
Yes,
now
we-
we will toggle this LED using switch. So just search LED. You will get PB5, PB0 and PB1. PB5 have LED 1, PB0 LED 2 and PB1 LED 3. Correct?
Yes.
So in IOC file, here PB5, this pin, this is LED pin, so we will make it GPIO output. Now second LED pin,
PB5, PB0,
PB0 and
PB1.
just select it GPIO output. Here I have selected PB0 and PB1 as GPIO output. Fine.
Yes.
Now in the schematic search switch SW. You can see switch 1, switch 2 and switch 3. So switch 1 on pin PC4, switch 2 on pin PD0 and switch 3 on pin PD1. Okay, PC4, PD0 and PD1. So
What is PC13? PC13?
PC13 it's open, so the connection will not be made here.
What does that mean?
There are two types of circuit, open circuit and closed circuit.
Okay.
So just take an example. You have a water pipe. Okay. And you have two ends, end A and end B. So if this pipe is closed, then water will flow from end A to end B.
Okay.
But if I open it in middle of point A and B, then what will happen? Will water reach from point A to point B, or it
No.
will? What will happen?
It will pass from that middle hole.
That middle hole. So our communication will not be made there.
Okay.
Similarly, closed circuits are the ones which are closed, where the communication will occur. Open circuits are like a hole. It is open. So if you want to transmit data through this, you need to make it closed circuit. But in our circuit, we need some open circuits also for some other purposes.
Okay. Okay.
That's
got
why
it.
this pin is configured here as closed circuit and open circuit.
Got it. Got it. Okay. Thank you.
Okay, so whenever you feel any doubt regarding closed circuit, open circuit, just think of the example of that water pipe. You will get clarity there.
Sure.
Okay, so now we have pins PC4, PD0 and PD1. I'll do it fastly. Search here PC 4. You can see here. Now LED pins are GPIO output and switches are input pins. So we will make it GPIO input. Okay.
Yes.
Similarly, we will make all the other two pins PD1 and PD0 as GPIO input. Any doubt till now?
No.
Nothing.
Okay. Now just go there, device configuration toolkit and click it. It will generate the main.c part. Fine. Now we want this LED toggling and its control using switches in continuous mode. So where we will write this code?
While.
In a while loop. So I have already made a project, but I'll explain you. Now our pins are in reset mode. Sorry, our pins are in reset mode. Like you have seen your. Have you seen switches in your home to control our electricity bulb or fans?
Yes.
So what happens when we press this switch, fan or electricity bulb, it turns on. And
Yes.
when we press it again, it turns off. So similar thing we will try to make it here.
So it is like pull up and pull down?
Yes.
Okay.
Okay. So you guys know how to write code of LED toggling. It's using HAL GPIO write pin, then giving the port of LED pin number and turn it on. You can use 01 here. LED toggling you guys have already done, na?
Yes.
Yes, yes.
So in this part of code, I think no one will have any issue.
Yes.
If anyone have any issue, I'll tell once again. But as we are running out of time, so I'm just making it fast. If any one of you have any issue, please speak. Any doubt or
No.
any issue? Okay. So what
No.
we have, yeah. So right pin will make LED turn on. Then we will make LED turn off. Similarly, we will do the same things for all the three LEDs. This will turn this LED off PB0, turn off PB0, then turn on PB1 and turn off PB1 here. Fine.
Yes.
Now we will come to the switch part, which I have not taught till now to you. So switch is input pin. LED was output pin, so we were giving command to it. Switch is input pin, so we will take command from it. So what we will do, if to give command, we write the pin, then for taking the command, what we will do?
Read.
We will read this pin. So I have just made a condition. If GPIO pin, I will read this pin. Which pin? PC4. That is switch 1. Switch 1 was on PC4, correct?
Yes.
So if PC4 pin is set, it means if it is pressed, then our LED first will turn on. And if it is not pressed, then we will go to the else part and the switch will be turned off. Sorry, LED will be turned off.
Yes.
So any issue till now? If this switch is set, if this switch is pressed, then our first LED will turn on. If this pin is not pressed, then our LED will not turn on. Fine.
Yes.
Similarly, we do the same thing for all the other two pins. Similarly, if switch 2 is pressed, LED 2 will turn on or it will get turned off. Similarly, if switch 3 is pressed, LED 3 will turn on or it will get turned off. Fine?
Yes.
Now just build this code. And we will debug it or run it. Okay, the code is downloaded in the controller. So now you can see I have pressed first switch, so LED blue is glowing. Can you see it? These two pins are for power.
Yes.
Just focus here. I have pressed this. Okay, so can you see this blue LED? Then with second pin and
Yes.
third pin. So there are three LEDs, blue, yellow and red. And they are getting controlled from this small three switches.
Okay.
Can you see this?
Yes, yes.
You can see these three LEDs and three switches. Once again, I'll show. I'll just press it. See this.
But Chandan, I think it is working in a reverse order when you are
Yes,
pressing.
yes. Yeah. I'll tell you.
Okay.
First, let's see. It is
Okay.
getting controlled from the switch.
Yes.
Similarly, second one, and third one. Yes. Can you see this?
Yes.
Okay. Now what happens? There are two terminals of LEDs, positive terminal and negative terminal.
Okay.
Okay. So first of all, I am just trying to explain it to you, all you guys, and that's why I'm handling this controller with my bare hand. You should never touch your controller with bare hands because short circuit or some sorting will happen there. So always use some protection like gloves or some instruments to demonstrate these controllers. Now what's happening here? There are two terminals in this LED, positive terminal and negative terminal. So by any chance, if you will, have you used multimeter?
Yes.
Okay, so multimeters are used to measure voltage, current and all things, resistance value. Okay.
Yes.
If you will connect one probe of multimeter with positive terminal of LED and other with negative terminal, then without anything this LED will turn on.
How?
It gets turned on because both positive and negative terminals get short circuited and the current passed through it using this multimeter.
Okay.
Okay, so LED turns on. What's happening here when I am using the, I am demonstrating with this controller using my bare hands. These LEDs and switches are very small, as you have seen in the video I have shown you just right now.
Okay.
So what's happening when I'm using my bare hand to touch it? These pins are getting sorted, and LED is getting turned on. But when I'm pressing the switch, then this minor sorting is getting removed. And when I'm pressing the switch, it is getting controlled through the switch, according to which we have already programmed.
So if we use some ESD gloves, then
Yes,
the issue
ESD gloves are the perfect things.
Okay.
In industry, we use only ESD gloves for these small PCB or layout or controllers. But even though by using bare hand, you can control it from here. As you can see, when I was demonstrating this controller to you, my connection got disrupted, and it's showing here target is not responding.
Okay.
So I'll connect once again. Okay. So if you want to prevent this minor sorting, then what we will do? Just give a small delay here. All delay and 1 second is fine. Similarly, yes.
Delay spelling is not correct. Delay spelling.
No issue with that. Yes. Similarly, give the delay to all these 3 LED toggling lines, and this issue will get sorted. Again, run this code. But it's not a perfect solution. I will always suggest you should use ESD gloves. I'll show you. Okay. Now you can see it here. Now. Okay, so just we have written code for one LED, so just focus on the first LED. It's in turn off state. Can you see it? You can now see only 2 LEDs. I just place my head. Then I will turn it on, and it's turned on.
Okay.
Okay, so it's getting turned off. Now I will press it.
I think you have to wait for 1 second.
Yes, yes. Now it's turned on. Again, it will turn off. Then again, I will press it. After 1 second, it turns on.
Okay.
Fine.
So is it like a debouncing concept?
Yes, this concept of providing some delay is known as debouncing in embedded system. When we will use accelerometer for our projects, there this debouncing term will be used quite frequently.
Okay.
Okay, so that's it for today's class. If you guys have any issue, then please speak up. Today we have covered 2 projects. One is of UART, and the other is of controlling LED with switches. I have also given all of you one small task, that is to transmit UART data in polling mode.
Yes.
Okay, so please try to complete it. And if you have any doubt, you can speak up right now.